Okay, so we have 7-4C, and the title is Writing Rational Expressions in Simplest Form. So our objective is to simplify expressions containing rational exponents. And with this stuff can be found on page 382. And really with this type of stuff, in the previous lesson we wrote rational expressions with rational exponents in radical form and radical form to rational exponents. And so what we're really going to look at today is just having rational exponents. So we'll have fractional exponents, which is fine, but following all of the exponent rules that we've learned in the past. So the directions, I'm just going to read them. It says, write each expression in simplest form and assume all variables are positive. So we're going to look here at number 1. So I have x to the 5th power raised to the negative 2/5 power. So just like any exponent rule that we have, if I have a power raised to a power, you need to multiply. So that means I need to multiply those exponents together. So that's actually going to be 5/1 times negative 2/5. I can diagonally reduce the 5's. So then I have x to the negative 2 power. Now, just like with the exponent rules that we've learned, you cannot have a negative exponent. So in order to make it positive, I need to move it to the denominator. So now I have 1 over x squared. So now this is as simple as I can get it because I don't have a negative exponent. Everything has been distributed with the power and all of that. So that actually concludes our first problem. Let's look at this second problem here. I have 7 times x to the 8th raised to the 1/5 power. Okay? Now, just like order of operations, you need to do parentheses, exponents, multiplication and division from left to right, and then addition and subtraction from left to right. So, well, within these parentheses, there's nothing to simplify. However, I do have an exponent. So I've got an exponent raised to an exponent. So I'm just going to, this 7's just going to come along for the ride and for the time being because I first need to take care of the exponents. So I need to do 8/1 times 1/5. That's going to be the exponent for x. There's nothing that I can diagonally reduce, so I'm just going to multiply across and I get 8/5. So that means I have x to the 8/5 power here. And now at this point, this is as simplified as it can get. And now I'm going to actually follow that multiplication. So I'm going to do 7 times x raised to the 8/5, and that is in its simplest form. I followed all of the order of operations and followed all of those exponent rules that I've learned before. Let's look at our third problem here. Number 3. I have 16 a to the 3rd power, b to the 4th power, all raised to the 1/2 power. So this is where it gets a little bit tricky. One, because I have a whole number raised to an exponent, so I really do need to utilize those tools from 7-4a when we were simplifying with those numbers. So first what I'm going to do is I need to do my exponent rule of having a power raised to a power. Please remember that this is 16 to the 1st power. So I'm going to distribute that 1/2 to the 16, to the a, and to the b. Okay? So now I'm going to have 16 to the 1/2 power because 1 times 1/2 is 1/2. a to the 3/2 power, because 3 over 1 times 1 over 2 is 3 over 2. And then b to the 2nd power, because 4 over 1 times 1 over 2 gives me 2. So now what I need to do, this is not quite in simplest form because I can handle this, okay? Remember that that to change this into a radical expression, the numerator is our exponent and the denominator is our root. So I've got the square root of 16. And the square root of 16 is 4. So I do need to, while these are okay, I can leave a to the 3/2, b to the 2nd power. I can leave that. That is fully simplified. If I ever have a whole number raised to that exponent, I do need to actually handle that exponent. The only time that you wouldn't is if I had like 16 raised to the 1/2 n power or something like that. Because you don't know what n is, you can't actually, figure out and calculate what that number is. However, I can do 16 to the 1/2 power, and that does give me 4. So then my final answer is going to be 4a to the 3/2 b squared. And that is now fully simplified. So let's go to our number 4. So number 4, I have b to the 6th power over b to the -2 power, all raised to the -3/4 power. So one approach, you can approach this one of two ways. I'm going to show you both. The first way that you can approach it is the fact that this is in parentheses and they both have the same variable. They're both b's. Also, this is a -2. So the way that I could approach this first is I could move the b to the -2 up to the numerator. So I'm going to have b to the 6th, b to the 2nd, all raised to the -3/4. And then again, I can still handle what's in parentheses, and I can do 6 plus 2, which is 8. So b to the 8th power raised to the 3/4 power. And now I can distribute this -3/4. So that's 8 over 1 times -3 over 4. So the 4 can reduce and the 8 can become a 2. So now I have b to the -6th power. And I cannot have a negative exponent, so I need to move it to the denominator. So that now becomes 1 over b to the 6th power. So that's one way you could approach this. Another way you could approach it is to actually distribute that -3/4 to both. So I would have b to the -9/2 there. I diagonally reduce the 4 and the 6 to get 6 divided by 2 is 3 and 4 divided by 2 is 2. All over b to the what? That's going to be a positive 3/2. Okay? So now what I can do is, because this is a negative exponent, I can bring it down. Let me just kind of do that. And then I have 1 over b to the 3/2, b to the 9/2. And now I can add those fractions together. So 3 plus 9 is 12. So then that actually gives me b to the 12/2. So that's going to be b to the 6th. So either approach is fine. It's just kind of however you prefer to approach it. A lot of times I prefer, because they're the same variable, I prefer to join them together. I prefer this first method that we did. But the second method, there's nothing wrong with it. I do have 2 more problems that you can see in the next video.